math lead. Whoop, whoop. All right, let's get into this. Learning target for today on 10.7 is I will solve exponential equations. Okay, take a minute, do your warm-up, ready, set, go. Awesome. I'm going to assume you've paused if you needed extra time. Well, you paused because you're going to need time. Some of these aren't that easy, but we'll get into that. All right, let's start off right here. Remember, combine like terms, and they both have square root 3, so 8 minus 2 is 6, and that's 6 square root 3. Boom, we're done. Right here, let's combine like terms. We have the square root 7 and the square root 7, so that's 18 plus 2 is 20 square root 7, and then minus 11 root 3. Okay, that's as far as we can go. Here's where it gets a little difficult. Now, I'm just going to move this over. You ready? I've written a whole list of squares here. Okay, on the left, perfect squares, right? So like this is 2 squared, 3 squared, 4 squared. Okay, and when I see a number like square root 96, and I'm like, I don't know what goes into that. What I'm going to do is I'm going to, first of all, I'm going to look at my list, and the highest I can go is 81 because 100 is too big. So this is 9 squared. Well, 81 is not going to go into 96 evenly. Neither is 64. 49 times 2 is what? 98, so that's not going to work. 36, does 36 go into 96? I don't think so, but I can just grab my calculator out. See, all right, 96 divided by 36. No, that has a decimal. Okay. So let's try 20. No, 25 is not going to go into it. It'd have to end in 0 or 5, and that doesn't. So I'm going to try 16. All right. 96 divided by 16. And what did that get me? Look at that, 6. Okay. So then I know that I can break this down into the square root of 16 times 6 minus. What goes into 24 that I can pull out of there? Well, that's 4 times 6, and 4 is a perfect square, so square root of 4 times 6 plus the square root. Now, notice both of these have a 6. I'm willing to bet that we're going to get 216 divided by 6 is going to get me what I need. So I'm going to try this. 216 divided by 6 equals 36, and that's a perfect square. We see it right here. See how I did that? Because I saw a pattern there, and I'm like, I bet they're going to try to get me to combine all these. Hey, use problem-solving skills. So this is 36 times 6. All right, so let's finish simplifying this. We're going to have, what? Square root of 16 is 4. So that's 4 root 6. Minus square root of 4 is 2 root 6. Square root of 36 is plus 6 root 6. And since these all have root 6, I can combine them. So that's going to be 4 minus 2 is 2. Plus 6 is 8. So this equals 8 square root 6. Boosh, right there. Good stuff. Okay. Now, looking at this one, I just know that 72 is 36 times 2. I just do. If you don't see that, you can go down the list, do the same thing, divide it in until you find one that works. But it's 36. So this is going to be the square root of 36 times 2z. Okay? Minus, and this one right here, 18, 9 goes into that, so that's the square root of 9 times 2 square root z. Which again, notice we have the two z's, okay? So what's the square root of 36 is 6, so that's going to be 6 square root 2z. Minus square root of 9 is 3 root 2z. And I can combine these. 6 minus 3 is 3, so this equals 3 square root 2z. Boosh, right there. Good stuff. Okay, let's go on. We're going to talk about today what's the definition of an exponential equation? Well, it's an equation in which the independent variable is an exponent. So an equation in which the independent variable is an exponent. So that's like what you're seeing right down here, okay? We have 3 to the x equals 243. See how that independent variable right there, x, is an exponent. It's in the exponent spot. And let's talk about the power property of equality. What is the power property of equality? Well, it says for any real number, I'm just going to put the pound or hashtag for number, that means number. For any real number, b is greater than 0, and b does not equal 1. Then b to the x equals b to the y if and only if. That means it's true forwards and backwards. X equals y. So in other words, if b to the x equals b to the y, then x equals y. And if x equals y, then we can say that b to the x equals b to the y. Works frontwards and backwards. What does that mean in practice for examples? Well, that means if 4 to the x equals 4 to the 5th, then x equals 5. I'm not spelling right today. It also means if n equals 2/5, then 5 to the n equals 5 to the 2/5. And last, but certainly not least, by the way, pause at any point if you need extra time. We know that if x to the 1/2 equals 3 to the 1/2, then x equals 3. Okay? And we're actually going to use this in different applications here in a minute. We're going to talk about that. It's going to involve some guess and check as we go. Make sure and pause this, get this written down, and then we just have 3 examples to work through today. First one's fairly simple. 3 to the x equals 243. Okay, so I need to find out, can I raise 3 to some power that's going to be 243? So I'm going to do that with guess and check. Let's try 3 up 3. 3 to the 3rd power. That's way too low. Okay, so 3 up to the 4th power. Still too low. Let's try 3 up to the 7th power. Skip a couple. Ooh, way too high. All right, 3 up 6. Still too high. Slide 3 up 5. It's our only hope. 243. So then I know I can rewrite this as 3 to the x power equals 3 to the 5th power. Why? Because I just did it on my calculator. 3 to the 5th power is 243. So now we have this exact situation where if b to the x equals b to the y, then x equals y. So I can now say x equals 5. Boom. That's a really simplified version of this. Now we're going to get a little more complicated. I've got 4 here, and I've got 256 to the x minus 2. Kind of ignore that x minus 2 for a second. I want to focus on the 256. I wonder if I can write 256 as 4 raised to a power. Since we have 4 over here, it would make sense. So I'm going to try 4 up. Let's go with 7. Whoa, way too high. Okay, let's try 4 up 5. Still too high, but definitely getting closer. Let's try 4 up 4. Look at that, 256. So I can rewrite this 256 as 4 to the 4th power. Why? Because we just proved it. 4 to the 4th power is 256. But don't forget, we raised that 256 to the x minus 2. And that equals 4 to the 1 power, right? There's a 1 there even though we don't see it. Okay, now, whenever we have a power to a power, and it's to that whole thing, then we have to distribute this. Remember, we multiply them together? So in other words, I'm going to have 4 times x minus 2, but I got to distribute it. So I'm going to have 4 raised to the, let's see, 4 times x is 4x. 4 times negative 2 is negative 8. And that's going to equal 4 to the 1 power. We're almost done. Now that I have the same bases, I'm going to set the tops equal. So I'm going to have 4x minus 8 equals 1. I'm going to add 8 to both sides. I'm going to have 4x equals 9. Divide both sides by 4, and I get that x equals 9/4. And that's it. Don't believe me that's true? Well, let's try it out. If I'm just going to check this up here real quick. So we'll draw a little line up here, do a little check. So that would be 256 to the, now 9/4 is 2 1/4. I only say that because, well, I guess I don't have to write that. That doesn't really matter. 9/4 minus, right? I'm just doing minus 2, and 2 is 8/4. I'm going to just make it into fourths, okay? 8 divided by 4 is 2, so that's just minus 2. 9/4 minus 8/4 is 1/4. So this equals 256 to the 1/4, which, if you remember, that is my, what do we call that, index number. So this equals the 4th root of 256. And what's the 4th root of 256? Well, we know 4 to the 4th is 256, so it makes sense. But let's prove it. I'm going to have 4, 6, remember that's how I do my 4th root on this, and it's 4. So this does indeed equal 4. Check, it works. Boom. I know it's a weird problem. It's a weird way to do it. We're going to try one more of these, okay? All right, last but not least, 625 equals 5 to the 3x minus 5. Let's try that. I bet I can raise this to some power of 5. So that's going to be, let's try 5 up 3. No, but let's try 5 up 4. There we go, 5 to the 4th power. So I know 625 is 5 to the 4th power equals 5 to the 3x minus 5, which means now I can set these equal to each other, and I get 4 equals 3x minus 5. Now let's just solve it. Add 5 to both sides. 9 equals 3x, and when we divide by 3, we get that 3 equals x. Boom, we're done. That's it. Okay, and again, we could check it if I wanted to check it. Let's see, I'd have 5 to the 3 times 3 minus 5, which is 5 to the 9 minus 5, or 5 to the 4th power. Look at that, which is the same as we have over here. We know 5 to the 4th is 625. Check, check, check. Okay? All right, that's it for today. With that said, peace out.